Hi everyone. In this video we're going to be talking about ratios and proportions. So let's start by talking about the definition of a ratio. What is a ratio? A ratio you can think of as a fraction. But there's other ways of thinking of ratios, but a fraction might be one way that you want to visualize this concept in your mind. A ratio compares values. More specifically, a ratio says how much of one thing there is compared to another thing. So let's start with a simple example. Here you can see that I have some apples and some oranges, and the question says, what is the ratio of apples to oranges? Right, so how many apples are there compared to how many oranges there are? Right, so there are 3 apples compared to 4 oranges. All right, so this is one way that we can express ratios with that little colon in the middle of the numbers. All right, so let's talk about other ways to express ratios. There are 3 different ways that we can express ratios. We can use the colon symbol to separate the values like you just saw. So like 3:4. We can also use the word 2 to separate the values. So we could say 3 to 4, 3 apples to 4 oranges. And lastly, we can write the ratio as a fraction. So 3 divided by 4. Here's our first example. There were 7 males and 12 females in the Dewdrop Inn on Monday evening. In the game room next door, there were 14 males and 24 females. Express the number of males to females at the inn as a ratio. Right, so again, we are going males to females. That's important. The order that you write the ratio in is very important. And not only are we comparing males to females, we're specifically looking at the males and females that were at the inn. All right, so how many males were at the inn? 7, right? And how many females were at the inn? 12. Right, so we can write that ratio as 7:12. There are 2 other ways we could write the ratio. We could say the ratio is 7 males to 12 females, or we could write the ratio as a fraction. Right, so any of these 3, any way that you write it, as long as it's one of these 3, would be totally correct. Right, so same setup, 7 males, 12 females at the Dewdrop Inn. In the game room next door, there were 14 males and 24 females. This time, we're supposed to express the number of males to females at the game room as a ratio. All right, so again, we're looking at males to females, so that's telling us the order in which we're going to write the ratio. And this time we're looking at the game room. All right, so males at the game room, there were 14. Females in the game room, there are 24. So the ratio of males to females in the game room is 14:24. We could write this 2 other ways. We can write it as a fraction. You do not need to simplify. It wouldn't be wrong to simplify, but you just don't have to. And then the other method that we could use to write the ratio is 14:24. All right, and then last question from this set. Express the number of males in the game room to the number of people in the game room as a ratio. All right, so a little bit more complicated this time. Number of males in the game room. All right, so number of males in the game room to number of people in the game room. All right, so how many males were in the game room? How many males were in the game room? 14, right? And what was the total number of people in the game room? That would be 14 males and 24 females. So add those up, that's 38. All right, so our ratio is going to be males in the game room, colon, number of people in the game room. So 14 colon 38. And of course, you could write this in our two alternative ways as a fraction or by separating the numbers with the word 2, so 14 to 38. All right, so our next topic is proportions. What is a proportion? Let's talk about what the definition of a proportion is. A proportion is an equation that shows that two ratios are equal. All right, so it's an equation, so it's going to have an equal sign, and we have two ratios. So typically how you will see this written is as, let's say, 14 over 24, I remember that was one of our ratios, equals another fraction. So let's say 28 over 48. All right, so you have two fractions that are set equal to each other. Okay, and with that comes the concept of cross multiplication. All right, so you're going to see some cross multiplication coming up here pretty soon. And let me just remind you of what cross multiplication looks like. Typically we'll have something that looks like this. Let's say 2 over 5 equals x over 10. All right, so when we cross multiply, we're going across the equal sign. So we're going across the equal sign. We're multiplying across the equal sign. So we're going to go 10 times 2 is 20. All right, and then 5 times x is 5x. Now that gets rid of our fractions and creates an equation that we can easily solve. All right, so we need to get x by itself, so we're going to divide both sides by 5. Right, that cancels out on the right, and we're left with x equals 20 divided by 5 is 4. All right, so just a quick refresher on cross multiplication, sometimes called cross product. Cross multiplication. So here's our first example with proportions. It says Josh can type 8 pages for every 4 pages that Dan can type. If Dan has typed 12 pages, how many pages has Josh typed? All right, so I want you to just focus on the first sentence to begin with. So just ignore that second sentence. The first sentence here says Josh can type, whoops, I got the wrong pen, I think. Let me go. Okay, Josh can type 8 pages for every 4 pages that Dan can type. All right, so my ratio is going to go Josh. Sorry, I keep losing my mouse. There we go. My ratio is going to go Josh, colon, Dan. All right, so that's the order that I'm choosing to write them in. You could put Dan first. There's no particular reason why I put Josh first. I just put Josh first because he was the first person that was named. All right, so Josh can type 8 pages for every 4 pages that Dan can type. All right, so the ratio of Josh compared to Dan would be 8 to 4. All right, now let's focus on the second sentence. All right, so let's erase that. Now we're focusing on the second sentence. If Dan has typed 12 pages, how many pages has Josh typed? So they kind of switch it up here, and they put the second sentence in the opposite order. They put Dan first, right? So you have to be careful with the order there. If Dan has typed 12 pages, right? So remember, Dan is the person that's on the right side of the colon. Right, so Josh is on the left side, Dan's on the right side. Did I say that right? I meant to say Josh on the left, Dan on the right. I may have said that backwards. And the new information that we've got is that Dan has typed 12 pages. So let me ask you this. How did we get from 4 to 12? What do we need to multiply by? 3, right? So we need to multiply by 3. Right, so we had to multiply by 3. Now we don't know how many pages Josh has typed, so I've just labeled that as X for right now. You could have left it blank, that wouldn't have been a big deal. Right, but we have to do the same thing to Josh's side. So we multiplied Dan's side by 3. Let's multiply Josh's side by 3. Right, so 8 times 3 is 24. Right, so the question is, how many pages has Josh typed? We would say Josh has typed 24 pages. All right, so we did this without having to set up a cross product or a cross multiplication problem, but you could have done this as cross multiplication. So 8 colon 4, we know that that could also be written as 8 over 4. Set that equal to, and then Dan had typed 12 pages. We didn't know how many Josh had typed, so we can label that X. Then you could cross multiply. But this one was kind of easy. So I think that our original method was probably the easier way. But if you want to do it the same way every time and you want to cross multiply every time, that way you kind of have a pattern set in your mind, then that is totally fine. You could have done it that way. All right, let's look at our last, I believe our last topic, and then we'll just look at examples. How to check if two ratios are a proportion. And we've already briefly mentioned this. We said that in problems involving proportions, we can use cross multiplication to test whether two ratios are equal and form a proportion. Right? So we know that anytime we're thinking about proportions, we want to have that, that tool of cross multiplication in the back of our mind. Right, so here's our next example. If there are 3 cars for every 8 students at a high school, how many cars are there for 1,200 students? Right, so the ratio of cars, right, so the ratio of cars to students is 3 to 8. And we're asked, how many cars are there if you have 1,200 students in total? All right, so I've labeled C for cars. So I've let cars be C, and then number of students is 1,200. So I've got cars on the left, students on the right. Right, so this one is not as easy. Like, it may not be right there on the tip of your tongue or right there at the forefront of your mind. Like, what do I have to multiply by 8 to get to 1,200? So you can do it that way. If you can figure out what do I need to multiply 8 by to get to 1,200, you can do that and then just do the same thing to the left-hand side. But I'm just going to show you how you can set this up as a cross multiplication problem. All right, so we would go over here and we would rewrite each of our ratios. 3 colon 8 could be rewritten as 3 over 8. C colon 1,200 could be rewritten as C divided by 1,200. So we just set those equal. Then we're going to cross multiply. 1,200 times 3 is 3,600. 8 times C is 8C. All right, so we have 3,600 equals 8C. All right, then we're going to divide both sides by 8. It's going to cancel out on the right-hand side, and you're left with C equals 450. All right, so that's our answer, and then we'll just put it in context. Anytime you're given a word problem, it's always nice to kind of wrap up the problem by putting your answer in context. All right, so C is 450. So we would say for 1,200 students, there are 450 cars. So the question asked how many cars are there for 1,200 students. So for 1,200 students, there are 450 cars. All right, so this one says, if it took 7 hours to mow 4 lawns, then at that rate, how many lawns could be mowed in 35 hours? All right, so I want you to try this one. So pause the video and try this one on your own. Then come back and check your answer. All right, so hopefully you've had time to pause the video and check your work. All right, so 7, I'm going to set up my ratio as hours. I'm going to do hours, colon, lawns. All right, so I have 7 hours, colon, 4 lawns. And I'm asking the question, how many lawns can I mow in 35 hours? So 35 is going to go first, remember, because hours is on the left of the colon, lawns is on the right. So I'm going to do 35 colon L. I'm using a capital L instead of lowercase because, you know, a lowercase L kind of looks like a 1. So I'm just using a capital L there to avoid any confusion. And I'm going to set this up as a cross multiplication problem, although I am noticing now that you could easily just say, to get from 7 to 35, we would multiply by 5. And then we do the same here. But like I said, I did originally set this up as a cross multiplication problem, so let me show you how I did that. Right, so I combined all of this information and I said the ratio 7 colon 4 could be written as 7 divided by 4. 35 colon L could be written as 35 over L. I set those equal to each other, cross multiplied. That gave me L times 7 is 7L, 4 times 35 is 140. Right, then I divide both sides by 7. Cancels out on the left. Right, and I'm left with L equals 20. Right, so totally fine if you did it the first way like I just mentioned. I'm just now noticing that that was an easy one, so you didn't necessarily have to set up a cross multiplication problem for that. Right, but our answer is 20, and to put that in context, we would say you could mow 20 lawns in 35 hours. Right, so I would say this is the most challenging problem of this unit. It says Kai, Paulus, and Judy made $2,520 for painting a house. Kai worked 30 hours, Paulus worked 50 hours, and Judy worked 60 hours. They divided the money in proportion to the number of hours they worked. If they all earned the same rate of pay, how much did each earn? All right, so let's think about this. We have 3 people working on a job. They all earn the same rate of pay. That's important. If they didn't all earn the same rate of pay, this problem would be much harder. But since they are all getting paid the same amount, this is actually going to be relatively simple. So let's think about this. In total, they made $2,520 for painting this house. Kai worked 30 hours, so 30 times the pay rate, because he gets paid for every hour he works. Paulus worked 50 hours, so that'd be 50 times the pay rate. And Judy worked 60 hours, so 60 times the pay rate. So combine all of that together, and we'll set it equal to what they got paid. All right, so we're gonna, in this example, I'm gonna let P be the pay rate. All right, so P is gonna be their hourly rate that they make. Right, so Kyle worked 30 hours, Paulus worked 50, Judy worked 60, and all together they painted the house. So we're going to put all those together, add them up. 30 times the pay rate plus 50 times the pay rate plus 60 times the pay rate. So 30 corresponds to the number of hours that Kyle worked, 50 corresponds to the number of hours that Paulus worked, and then 60 corresponds to the number of hours that Judy worked. And when you add up all their hours together, we set that equal to what they got paid. All right, so we've got like terms over here, so we can go ahead and combine those. 30 plus 50 would be 80, plus 60 would be 140. So that's 140p equals 2520. We're going to divide both sides by 140. All right, so divide by 140 on both sides. That's going to cancel. And we're left with P equals 2520 over 140 is 18. All right, so that's their pay rate. So to put this in context, the question said, how much did each earn? So we would say each of the workers earned $18 per hour. The last thing I want to talk about is how you can use bar models to solve ratio and proportion problems. All right, these are also sometimes called maybe like paper strips. I want to say they're sometimes called paper strips. Okay, I paused the video and looked it up. It is sometimes called a bar model, sometimes called a strip diagram, and also called a tape diagram. All right, so bar model, also known as a strip diagram, like a strip of paper. Or it could be called a, what did we say? Tape. Yeah, a tape diagram. And I'm thinking like a measuring tape. All right, so sometimes called a strip diagram or a tape diagram. But this is kind of a fun and interesting way to get your students engaged in the proportion problems, but also to help them conceptualize the idea of fractions and parts and wholes. Right, so here's a problem that at first glance seems pretty complicated, but when you write it out using this bar model or strip diagram, it's actually pretty simple. It says the ratio of 8th graders to 7th graders at a meeting is 4:7. All right, so for every 4 8th graders, there are 7 7th graders. Right, so more 7th graders than there are 8th graders. And it says if 1/4 of the 8th graders are males and 2/7 of the 7th graders are males, what is the ratio of boys to students at the meeting? All right, so we're going to start by just drawing out our little bar models or our little strip diagrams. All right, so you can see I've got 4 to 7. So this is my 8th graders up here at the top. And then my 7th graders at the bottom. So I've got 4:7. 4 8th graders for every 7 7th graders. Looking at this first sentence here, 1/4 of the 8th graders are males, okay, and 2/7 of the 7th graders are males, okay. We'll worry about this second part of the question in just a second, but let's take and shade in our little bar models to correspond to the males. 1/4 of the 8th graders are males, so we're going to shade in 1 out of the 4 squares. We also said that 2/7 of the 7th graders are males. All right, so here's our 7 boxes. We're going to shade in 2 of them. Okay, and now we can figure out the ratio of boys to students. All right, so that's the way we're supposed to be writing the answer here. Boys, students. All right, so count up. All these boxes represent the total number of students, right? So 1, 2, sorry, let me switch to my laser. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so 11 students in total. And out of those 11, 1, 2, 3 are males. All right, so the ratio of males to students is 3:11. Again, you could also write this as 3 divided by 11. All right, so you could do 3 over 11, or you could also say 3 to 11 would be fine as well. All right, last problem. Your friend is making cookies. He tells you that he is supposed to combine butter and flour in a 4:9 ratio. He used 30 grams of butter. How much flour should he use? All right, so let's look at our ratio. All right, so butter to flour is 4:9. All right, so for every 4 grams of butter, he's supposed to use 9 grams of flour. All right, so for every 4 grams of butter, we're supposed to use 9 grams of flour. All right, so we've got butter and flour. All right, second sentence. He used 30 grams of butter. All right, so it says that these 4 little boxes combined to 30 grams of butter. All right, so those 4 boxes totaled up to 30 grams of butter. So if you divided 30 by 4, what do you get? All right, pause the video if you need to grab your phone or your calculator. What's 30 divided by 4? That's going to tell us what each box represents. All right, so 30 divided by 4 is 7.5. All right, so 30 divided by 4 is 7.5. So each little box represents 7.5 grams. Now, if we put 7.5 grams in every one of these boxes, right, so 7.5, 7.5. You can add this up 9 times, that's fine, but what would be the faster way to do this? Multiply 7.5 times 9, right? Right, so you could do 7.5 times 9. Right, so add that up 9 times. That equals 67.5. Right, so that's our answer, and to put that into context, we would say your friend should use 67.5 grams of flour. Right, so that's everything for this video. If you have any questions, please let me know, and I'll see you guys in the next video.